The next section is the double angle functions. These are also on your formula sheet. So we have the functions of the double angle: sine, cosine, tangent. And I've written them right here. The biggest problem with this section is simply that for the cosine of a double angle, we have 3 choices. So sometimes it's hard to figure out which one would be the best choice. All of them will work, it's just which one makes the algebra easier. So if we have a double angle for sine, it equals 2 sine A cosine A. For the double angle of cosine, we can have cosine squared A minus sine squared A, 2 cosine squared A minus 1, and 1 minus 2 sine squared A. It's really just making a substitution. Go back to your Pythagorean identities. We have the Pythagorean identity of sine squared, I'll use A in this case, plus cosine squared A equals 1. So if you substitute in for cosine squared, or you substitute in for sine squared, that's where the 3 formulas come from. It's by making a substitution of the Pythagorean identity. But we'll talk more as we do each problem which one works better. So let's go to the next page, start with something simple. Tangent theta is in the second quadrant. So here's our second quadrant. Tangent is opposite over adjacent. And we have to figure out the negative. So remember, when you're graphing, you go over negative, up positive. So the negative goes with a 3. So just like before, do your Pythagorean theorem and figure out your missing side. So square root of 7 squared plus negative 3 squared equals c squared. So square root of 7 squared is 7, plus 9 equals c squared. 9 plus 7 is 16. C is positive or negative 4. Remember, your hypotenuse is always positive. Okay, so secant is 1 over cosine. Cosine is adjacent, right? Cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. So the secant of theta would be 4 over negative 3. Cosine then is just the reciprocal of that, so we don't have to redo it, just take the reciprocal, negative 3 over 4. Sine. Sine is opposite over hypotenuse, so square root of 7 over 4. Okay, nothing new. Let's go to a double angle. Sine of 2 theta. Sine of 2 theta equals, go to your formula, 2 sine theta cosine theta. So you can look, we already did most of this right here, or just go back to your triangle. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Or you could have just looked up here. Multiply your top. 2 times negative 3, negative 6 times square root of 7. 4 times 4. Remember, you can write this over 1 if it helps you. And we can reduce by 2. So we get negative 3 square roots of 7 over 8. Cosine 2 theta. 3 choices, like we already said. In this case, it doesn't matter which one we pick. Just pick any of them. I'm going to do 2 cosine squared theta minus 1. Cosine, negative 3 over 4. So negative 3 over 4 squared minus 1. So 2. 3 4 squared is 9/16. 2 times 9 is 18. 18 over 16 minus 1. Change our 1 into sixteenths, so 16 over 16 equals 2 over 16, or 1/8. Now, tangent to theta has a formula. If you look at your formula sheet, it's not written on the front of this packet, but 2 tan theta divided by 1 minus tangent squared theta, or a in this case. But also remember that tangent is sine over cosine. So if we're just doing the tangent, we're going to use that formula. But since we already did the sine and the cosine of the double angle, the tangent of 2 theta equals the sine of 2 theta over cosine. Right? Go back to your quotient identities. So we already have these. What's the sine of 2 theta? Right here. What's the cosine 2 theta? Right here. So -3 square root 7 over 8 divided by 1/8 multiplied by 8 over 1. 8's cancel. -3 square root of 7. So that's your answer for tangent, cosine, and sine. It's fairly simple. Use the formula, plug it in. Okay, quadrant 2 again. Cosecant, reciprocal of sine. So if cosecant theta equals square root of 5, we can call it over 1. Then the sine theta equals 1 over the square root of 5. So here's your theta. Sine is opposite over hypotenuse. Got to figure out your missing side. So 1 squared plus b squared equals the square root of 5 squared. So 1 plus b squared equals 5. B squared equals 4. B equals positive or negative 2. So here in the second quadrant, x value is negative, so negative 2. So now use the formulas. Find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. And this time I'll use the tangent formula. Okay, so try that on your own. Pause the video, try it on your own, and then come back and see if you have the same answer as I do. Okay, so for sine 2 theta, 2 sine theta, cosine theta. Sine is 1 over the square root of 5. Cosine is negative 2 over the square root of 5. 2 times 1 times negative 2, negative 4. Square root of 5 times square root of 5, 5. Cosine 2 theta, I used 1 minus 2 sine squared theta. You could have used a different one, makes no difference. Plugging in 1 over the square root of 5 and squaring it, you get 1/5 multiplied by 2. 1 minus 2/5 is 3/5. Tangent, again, you could have done this divided by this and came up with this answer, which is perfectly fine. Just wanted to practice using the formula. So plug in your tangent. So 2 times 1 over negative 2 is negative 1. 1/2 squared is 1/4. 1 minus 1/4 is 3/4. Negative 1 divided by this, multiplied by the reciprocal, you get negative 4/3. And of course that checks out if you divide these two. Okay, again, all this so far fairly simple. Next page we're going to try proving an identity. So again, as soon as you see the 2 theta, you're thinking, look at my formula sheet. So we're going to leave cotangent theta alone. Substitute in here. Sine 2 theta is 2 sine theta cosine theta. 1 minus cosine 2 theta. So here comes the problem. Which formula do we use? Okay. Remember that on that problem I have 1 minus something, right? So if I pick this one, see how the ones will cancel each other out? So that's the one I'm going to pick, simply because the ones will cancel each other out. So So first step is going, we want to write, doing a proof, we want to write vertically. So the only thing I'm going to do in this step is take the ones and cancel them. Now the other thing you have to remember is you're really multiplying through by a -1. So don't forget to carry that negative. So we have 1, maybe we'll write it all out, 1 minus 1 plus 2 sine squared theta. Okay, now you can see the ones cancel. So I have 2 cotangent theta equals 2 sine theta cosine theta over 2 sine squared theta. Ignore the homework. So what cancels now? Well, you should see the 2's cancel. And we have a sine divided by a sine squared, so think of that like x over x squared, right? One of the x's will cancel. So the sine cancels with one of the sines. So cotangent theta equals cosine theta over sine theta, right? And that's the quotient identity. Cotangent is equal to that. So then we write cotangent theta equals cotangent theta. So these are fairly simple as far as proofs go. The biggest thing always is when we have a cosine squared, picking the right one. And it's not that any of them are wrong, it's that we want to pick one to make the next steps easier. So look at what you have and what could cancel in determining what you're going to pick. Okay, and we'll practice some more of those in class. All right, last is the half angle formula. So that was the double angle. Now we're going to use the half angle formulas. So if you look on your sheet, here's your half. Ooh, too far. Half angle formulas. Okay. So sine of a half of an angle, cosine of a half of an angle, tangent of a half of an angle. So again, we're on the reference sheet. Same idea, we're setting up the triangle. It's in the third quadrant. Angle is A, sine is opposite over hypotenuse. Remember, the hypotenuse is always positive, so this will be negative. Do the Pythagorean theorem. Square root of 5 squared plus b squared equals 3 squared. 5 plus b squared equals 9. B squared equals 4. B equals positive and negative 2. So again, you got to think third quadrant, negative, negative, so it's a negative 2. Okay. So, half angle, you're just going to the formula sheet. The sine of 1/2 A equals sine of 1/2a plus or minus 1 minus square root of 1 minus cosine a over 2. Okay, simply plugging in. What's the cosine? Go back to your triangle. Cosine is adjacent over hypotenuse, so 1 minus negative 2/3 over 2. And we just have to do some algebra, and that's it. Minus is a plus, so 1 plus 2/3 over 2. So 1 is 3/3, right? We can rewrite 1 as 3/3, so we have 5/3. So 5/3 divided by 2 is 5/3 times 1/2, which is 5/6. So this equals the positive or negative square root of 5/6. Now, if you're asked to rationalize it, we can rewrite it as square root of 5 over square root of 6. Multiply by square root of 6 over square root of 6. So we have plus or minus the square root of 30 over 6. And 30 can't be broken down any further. So we're done. Alright? So, half angle formulas, double angle formulas, you're just using the formula sheet. Half angles, very infrequently do we see those, but again, just use the sheet and plug it in. And we'll practice these in class. See you next time.